So far, we have been looking at some of the MC questions regarding three-dimensional problems. Now, we can start looking at some of the Section B questions. Now, Section B is the basis for Level 4 and Level 5, alright? For Level 4, you have to attempt some of the Section B question. If you want Level 5, you have to take Section B very seriously. Now, because these are where the difficult topics and the difficult questions are. So, now let's start looking at this one. This is one of the easier Section B questions, so to speak. So we have a pyramid, but it is tilted at one side. All right. So we have this. Now, the first important thing is to put back the number in the proper place. All right. Now, in my strategy, I will put them in the same color. Right. So all the AB will be 18. All right. So this is 18. Now, not just this AB, we know that it is a rectangular base, right? Remember, one word encapsulates a lot of meaning. Rectangular base means that this DSE is also the same 18, all right? That might be useful later on, right? And then let's look at other lines. We have a BC equals to 10, so BC will be this one, right? I try to use the same color to represent lines of the same length, all right? So and then what else? We have VB and VC. They are 30. So this is VB, all right, and this is VC. In green, they are 30, all right. So in green we have 30 cm. In red, 18. In blue, 10, all right. Now, in addition, we know that the angle VAB is 110 degrees, and also the same for angle VDC, right? So this VAB is 110 degrees. So is VDC, right? So you see this figure is left-right symmetric, right? You can have a mirror in between and the whole thing is left-right symmetric, okay? So first of all, we want to find the angle VBA. We want to find this purple angle, all right? Okay, so first of all, we have to discover the focus triangle. Alright, and then we see can we gather 3 pieces of information from this focus triangle. Now the purple angle VBA lives on this triangle, right? It survives on this triangle. So I guess we will use this triangle as the focus triangle. This is VAB, alright? Remember I said the red lines, they are all 18. Alright, the green lines, they are all 30. Alright, what else do we know? Oh, we know that in addition, we know that this orange angle is 110. Alright, so we have 3 pieces of information in this triangle. Unfortunately, they are in the SSA configuration. Alright, so we have to be mindful about SSA because it is an ambiguous case. Alright, and if you know about SSA, there is no direct way to find this purple angle. You can use cosine formula to find VA. Alright, there might be 2 answers. You can use the sine formula to find this angle V. Once again, use sine formula to find angle. There might be 2 answers. Alright, so we have to do it one way or another. You can do it with the cosine formula, get the VA. Alright, this is method 1. Let me put it down clearly. Alright, method 1, we use SAS cosine formula to find VA, alright. We net VA equals to A, for example, and then we use SAS cosine formula, set up an equation to find quadratic equation to find A, alright. And then once you have VA, we can then use triple S cosine formula to find angle VBA, to find the purple angle, alright. So these are the 2 steps in method 1, making use of cosine formula. Alright, method 1, step 1 will be like this, step 2 will be like this. Or you can attempt method 2. Alright, method 2 uses sine formula. Use sine formula to find angle V. Alright, angle AVB. And then secondly, we use angle sum of triangle. We use angle sum of triangle to find angle VBA. Alright. So I guess method 1 is easier, right? Because the step 2 in method 1 looks easier. So we can do that with method 2. Let me give them names so that there will be easier reference in the future. We call this alpha, okay? So on one hand, we have sine alpha divided by 18 is sine 110 divided by 30. Sine 110, alright? This is 18, this is 30. So we can have alpha equals to, let me see, the calculator shows it is 54.3201. Right? I try to use more decimal places for the intermediate result to boost the accuracy. Now this is the answer the calculator gives me, alright? But don't forget that for inverse sine function, there is the possibility of an alternate answer. Alright, there is a possibility that it is 180 minus. Alright, it is an obtuse angle. But we know that there is already a 110 in this question, in the orange angle. So the obtuse angle is not possible. We can never have two obtuse angles in one triangle. Alright, so this answer is not accepted. Alright, fortunately, there are two answers, but it goes down to just one answer because one of them will make the angle sum of triangle greater than 180. Alright, so alpha must be an acute angle, so alpha is 34.3201. With alpha, we can use angle sum of triangle. This is step 1, alright. In step 2, we can use angle sum of triangle, angle sum of triangle to get the purple angle. Angle sum equals to 180. So right away, we have angle VBA equals to 55.6799 degrees, alright? Or in 3 significant figure, it goes to 35.7 degrees. Okay, so this is the answer to part A, alright? There are two methods in an SSA triangle. You can use the cosine formula to get VA, and then using triple S cosine formula to get theta. Or you can use the sine formula to get alpha, and then you use angle sum of triangle to get the theta as well, right? If you don't know how to do that, you can go back to the SSA video to revise on these two methods. Alright, what's next? And then in part B, it says that it marks the midpoints. Alright, and then there is a trapezium, PQNM. Alright, we want to, a craftsman claims that the area of the trapezium is less than 70. Do you agree? Explain your answer. So let's look at the trapezium. Alright, now first of all, remember, all these blue lines, they have the same length, right? It is a rectangle. So therefore, this PQ blue line will also have the same length. It is a rectangle after all, alright? So it must be 10 for the blue line. Right, so how about MN? Let me change to a lighter shade of blue, right? This is MN. Alright, how about MN? We know that according to the midpoint formula, the midpoint theorem, we know that in a triangle, right, if you mark the midpoints, then the length of the midpoint, the separation between the midpoint is half that of the baseline. Alright, so if this is 5 down, if it is 10 down there, it should be 5 up here. Alright, because it is the midpoint of the triangle. Alright, that is the midpoint theorem, isn't it? So in no time, we obtain MN equals to 5. Because it is the it is an midpoint theorem in triangle VBC. Alright, so we have this blue line equals to 5. Now and then we need to find the line MP. Alright, okay, let me use pink to indicate MP. Alright, so once again, if you look at the diagram here, MP will be just this line. Alright, MP will be half of VA because once again, this is the midpoint. Alright, in VB and AB. Alright, so we have the pink line MP is half of VA. The pink line is MP and is half of VA. To find VA, we can use if you use method 1, if you previously used method 1, then right away you have VA. If like me you use method 2 here, you can calculate VA using SAS cosine formula. Alright, in this triangle, you can use SAS cosine formula. In this triangle, you can use SAS cosine formula to find VA. Alright, so we have VA equals to the SAS cosine formula. We have this red line is 18. Sorry, we have this red line equals to 18. The green line is 30. The green line here is 30. Alright, and the purple angle, we know what is the size of the purple angle. The purple angle will be 55.6799 degrees. Alright, so with this information, you can find VA. Alright, using SAS cosine formula, and divide by 2, we have the length of VP. Alright, and that is 9.310. Alright, that is the length of MP. Alright. So now with MP, now we have the complete trapezium. The trapezium will be like this. The baseline is 10. The top line is 5. Alright, and then the two lines will be the same because it is left-right symmetric. Remember. Alright, so according to the color, it will be like this. This is 5 on top. This is 10 at the bottom. So all we need to do now is to calculate the area of this trapezium. If it is greater than 70, then the claim is correct. I mean, if it is less than 70, then the claim is correct. Otherwise, it is wrong. Alright. So but to find the area of the trapezium, we need to have the heights. Alright, now we have the upper base and the lower base, but we don't have the heights. For the heights, we can use Pythagoras theorem to get the heights of the trapezium, because the baseline can be broken down into 5 and 2.5 and then another 2.5, right? It is left-right symmetric, like I said before, right? So you can break down the baseline into 5 and 2.5, alright? So using trapezium, we can get the length of the yellow line. The height of this trapezium will be the yellow line, and that is the pink square. Never mind, right? The pink square. Subtract 2.5 square minus 2.5 square, and then you take the square root, right? That is the yellow line, and the length of the yellow line goes to 8.9681. All right, the length of the yellow line goes to 8.9681 cm. All right, we use Pythagoras theorem to get the height of the trapezium. So now with everything together, we can have area of the trapezium, PQNM, equals to half upper base plus lower base. Upper base is 5, lower base is 10, alright, and then we multiply to the heights, 8.9681, alright, and this answer turns out to be less than 70, alright, so the claim is correct, agree, alright, because the area turns out to be less than 70. Alright, so this is it. I tried to cram everything onto one page, so it seems quite messy here. But I hope if you follow the procedure, you know what to do, right? Now, let's recap. The important thing in this question is you have to look at which line is, how long is each line, alright, from the question. The method that I use is to color each line so that you know each line will have a different color, so that the same color will correspond to the same line, alright? And I use the cosine formula and sine formula alternatively to achieve the best result.